Hi, this is the homework, end of Investigation 2 homework review. And Investigation 2 was all about scale factors and similar shapes. So I wanted to throw in some homework problems, extra age problems, that would help review some of the concepts that we've talked about. The first problem had a list of different shapes, and you had to find two sets that were similar. And this one was a little tricky because one of the sets was congruent in addition to being similar. It turns out that these two rectangles, ABCD, and IJKL are similar. They have the same shape, and there's a scale factor that makes one go from the smaller one to the larger one, or the larger one to the smaller one. The other set that is similar are triangles D, F, and E, this one right here, and XYZ, which is this one right here. And like I said, not only are they similar, but they have the exact same angles and measurements, so they are congruent also. When asking for corresponding sides, what they're trying to say is that when two shapes are similar, they have sides that line up with each other. So in this particular case, if we go back to A, B, C, and D, we can see that A and B correspond with J and I. D and C correspond with K and L. A and D, J and K. B and C, I and L. So those were lined up perfectly, so it's a little bit easier to tell which ones correspond. And jumping ahead to corresponding angles with these, again, they're lined up exactly right. So A corresponds with J, B corresponds with I, C corresponds with L, and D corresponds with K. In the case of our two triangles, they're not lined up exactly the same. So you can either flip them or rewrite it like on a separate sheet of paper so you can see easier what lines up and what doesn't line up. Or you can just try to guess. But in this case, it turns out that FE, which is the side across from the right angle, is the same as YZ. ED, which is this one, is the longer side. That corresponds with XY. FD corresponds with XZ. Again, X corresponds with D, Y corresponds with E, and Z corresponds with F. So you should be able to do that. You should be able to look at a couple of shapes, figure out if they're similar. If they are similar, you need to also figure out the scale factor between them, and you need to be able to figure out corresponding sides and corresponding angles. And with our case of our triangles, the scale factor is just 1, because you multiply each side by 1 to get the other triangle. In the case of these rectangles, if you're going from the, I believe the question down here asked, to going from the larger figure to the smaller figure, well, if our larger figure is 3 and our smaller one is 2, then our scale factor is 2/3. The scale factor from the larger to the smaller figure for the rectangle is 2/3. Scale factor for the triangles is 1. Again, they're congruent triangles. Find each quotient. So quotient is division. It means do division. And remember, when you're dividing fractions, you invert the number that you're dividing by, and which means flip it and then multiply. So instead of 1/2 divided by 1/4, you have 1/2 times 4/1, or 4 divided by 2, which is 2. 1/4 divided by 1/2 is 1/4 times 2, which is 2/4, which is 1/2. 3/7 divided by 7/4 is 3/7 times 7/4, which is, the 7's actually cross out, so it ends up being 3/4, or it would have been 21/28, which is still 3/4. Here we had 3/7 divided by 4/7. Here we have 4/7 divided by 3/7. So we just swap the order. And in this case, instead of 3/4, we get 4/3, or 1 1/3. 3/2 divided by 3/5 is the same as 3/2 times 5/3. So that's 15/6, right? So 3 times 5 is 15, 3 times 2 is 6, or again, the 3's cross out, so it's just 5/2, or 2 1/2. 1 1/2 divided by 3/8, you convert 1 1/2 to 3/2. 3/2 times 8/3 ends up becoming 8/2, which is 4. And our secret word will be, what was last night? The Oscars, right? So Oscar is our secret word for this homework. If you watch this homework, then you'll know that the secret word is Oscar. This last one problem, I like it. I think it's, or second to last, number 31, is a challenging problem, but I think it's pretty doable. You may need to draw some pictures to try to figure it out. Actually, probably drawing it out would be the clearest way, but you can also kind of figure it out just by looking at the points. So you have three triangles. Triangle ABC has these 3 points, 1, 2, 4, 3, and 2, 5. The next set of triangles are 3, 6, 12, 9, and 6, 5, 6, 15. And you need to come up with a rule that will get you from triangle ABC to triangle DEF. Looking at it, how do I get from 1 to 3, 2 to 6, 4 to 12, 3 to 9, 2 to 6, and 5 to 15? Well, in each case, you can get from the old x value to the new x value and the old y value to the new y value by multiplying by 3. So this is a similar triangle that's 3 times bigger. So our rule is 3x, 3y. Okay, so now we want to go from DEF to GHI. We need to figure out again what's our rule. How do we go from 3 to 5, 6 to 9, 12 to 14, 9 to 12, 6 to 8, 15 to 18? Well, I don't see anything that's obvious multiplication. I'm not multiplying 3 by 2 to get 5, and I'm not seeing anything like that or even division to make it smaller, but I do notice that I can add values. In each case, when I go from 3 to 5, I'm adding 2, 12 to 14, I'm adding 2, and 6 to 8, I'm adding 2. So my rule for my x values will be x plus 2. For the y's, I'm going from 6 to 9, 9 to 12, and 15 to 18. So in that case, my y's are changing by values of 3. So my rule would be y plus 3. So again, going from triangle DEF to GHI, my rule is add 2 to my x value, add 3 to my y value. Now here's the challenging one. If I want to go directly from ABC to GHI, how do I do it? How do I go from 1 to 5, 2 to 9, 4 to 14, 3 to 12, 2 to 8, 5 to 18. Hopefully you didn't spend a lot of time just trying to figure out what rules would make it, because hopefully you realize that you're just adding the 2 rules that you've done together. In order to go from the first triangle, A, B, C to DEF, I multiplied them both by 3. And to go from DEF to GHI, I added 2 or I added 3. So your final rule, if you combine them both to go from the original to the last triangle, is 3x plus 2 and 3y plus 3. So if you combine the 2 rules, you tripled your x and y to make it 3 times bigger, and you've added 2 to move it to the right 2, and you've added 3 to move it up 3. So the last step is to combine the 2 rules together. And our last problem is back to Mug. If you drew Mug and his hat on the same grid, his hat would be off at his feet instead of on his head. Because remember, we had a problem a couple days ago where we had Mug's hat and we drew it on the grid, but it was low. It didn't really go where it belonged. It belongs on Mug's head. So how do we get it on Mug's head? Well, we don't want to change the size at all. The size is actually pretty good for Mug's head. We don't want to make it any bigger. We just want to move it over and up. So I don't want it quite here. I want it over 1 more. So to go over to the left 1 means I subtract 1. That's what I'm doing here. X minus 1 will move my hat to the left 1. Now I want to make this bottom line be on top of Mug's hat. So in order to be on top of Mug's hat, I have to go up 1, 2, 3, 4, 5, 6. So I'm adding 6. So my rule to center Mug's hat on his head would be move to the left 1, up 6. X minus 1, y plus 6. Now we're saying, well, let's pretend it's not Mug's hat, but it's Zug's hat. Zug is twice as big as Mug. So how do I take this hat here that's designed for Mug and is low to make it doubled to go on Zug and move it up? So the first thing I have to do is make his hat twice as big. In order to make the hat twice as big, I would do 2x, 2y. But now my Zug is also twice as big. So instead of moving it over 1, I need to move it over 2. So I go to the left 2. And instead of going up 6, I'm going up 12. So I have to double everything. I have to double how far I'm going to the left, how far I'm going up, my x and my y. So if you wanted to put Mug's hat on Zug and make it fit, then you would have 2x minus 2, 2y plus 12. We doubled it, we moved it to the left, and we moved it up. That is the end of this review homework. We'll start investigation 3 tomorrow. Thanks.